they are ready to kick off. Yep, we have the thumbs up from our judges. So Team 6, over to you, and very good luck from me.
Thank you, Siobhan, and I'll be doing the screen share on my end. So just like to confirm that the home screen is up.
That's brilliant. Thank you.
Okay, Siobhan, on your go. Thank you.
Thank you. Over to you, starting now.
Thank you. Good afternoon, judges. My name is Daniel Mateus, and today I'll be presenting alongside my colleague Lucas Coletta. Thank you for taking the time today to hear our team's proposal on analyzing existing data to better target energy efficiency spending. Our idea addresses the urgent need to meet Canada's climate targets, such as those outlined in the Emissions Reduction Plan, which aims for a 40% reduction of GHG emissions from 2005 levels by 2030 and net zero by 2050. However, current projections do not have Canada reaching these targets. For our idea, our team has focused on analyzing data related to the substantial portion of emissions that come from residential buildings, one of the sectors identified by Environment and Climate Change Canada as having the greatest potential for achieving reductions. Around 10% of total GHG emissions come from the residential building sector, and most homes that Canadians live in today will still be in use 30 years into the future. That means that nearly every one of these existing units will need to be retrofitted with installations that encourage greater energy efficiency. And considering that Canada is projected to require almost 4 million additional housing units by 2030 to restore affordability, emissions are going to continue to compound. Our idea will present a data-driven approach that supports a cost-effective method for delivering these retrofits. The government has invested over $15 billion in home retrofit programs, with half of that going to three major programs: the Greener Homes Grant, the Greener Homes Loan, and the Oil to Heat Pump Affordability Program. The question we asked was, is the government leveraging the best data available to inform these program decisions? Here we arrive to the EnerGuide rating system, something you may be familiar with if you've ever had a retrofit done to your house. Functioning as an energy assessment tool, it holds over 400 fields of data for each individual home energy evaluation. We propose leveraging the EnerGuide rating system, a comprehensive database with information on over 2.3 million homes, and linking it to a database of invoice and costing data from homeowner retrofits to enhance decision-making and program design. Despite their value, we have identified shortcomings in how these datasets are being utilized. For example, the EnerGuide rating system does not present data on individual retrofits and instead groups the result of a home energy evaluation into one report. The extraction process to populate the costing database is manual, a time-intensive, inefficient process that lacks validation. Both challenges lead to a difficulty in optimizing government spending on investment programs highlighted earlier, as there's no way to accurately connect each dollar spent to GHG emissions saved. Importantly, all these challenges contribute to a lack of information and in turn a lack of transparency about costs and savings for both the government and the public. I'd like to present a practical example to really highlight this problem based on existing data. There are a number of ways to achieve energy savings depending on what particular retrofit is chosen for your home, such as insulation, changes to windows, or upgrades to a heating and cooling system. For example, if a homeowner wants to achieve energy savings of 13% in their homes, currently they can spend in a range of $58,000 to $83,000. The range of $25,000 exists because for a given percentage of energy savings, cost differs based on which retrofit upgrades are chosen and which supplier you choose. This lack of knowledge on value for money is a direct result of not using the data available to understand how each individual retrofit affects energy efficiency. Our idea aims to bridge this gap by utilizing readily available data through a clear implementation process. To explain our proposed idea in more detail, I'll turn it over to my colleague Lucas.
Thank you. Earlier, Daniel posed the question, is the government using the best data available? The answer is no. The good news, however, is that we own and have access to the best data. We just need to make it useful. Our idea for the Public Service Data Challenge is to optimize home energy retrofits by combining enhanced energy savings data along with costing data. We aim to accomplish this through four key activities. First is to embed new calculations in the existing ERS database and HOT 2000 energy modeling software. This will enable us to extract energy savings from individual retrofits and offer a more accurate analysis of energy and GHG savings. Second is to leverage AI and machine learning to extract retrofit costing data from invoices submitted through retrofit programs. This will create access to data points that we never had and significantly improve the accuracy and efficiency of the data extraction process. Once we have our energy savings data and our costing data, we can undertake our third activity of merging these two data sets together to offer a more comprehensive and accurate set of regional information. The ability to reference and analyze costing data and energy savings data from up-to-date sources is extremely important for decision makers at all levels. And lastly, and possibly the most important, is making this data accessible. Our goal is to publish the new data set on Open Government. We have heard from stakeholders across the home building industry that this information is of great value to them, and creating public access will significantly improve its impact. To improve the usefulness of our energy modeling data, we are proposing to embed 438 new equations and 46 validations into NRCan's HOT 2000 software. These equations have been developed and validated by NRCan engineers. The equations focus on disaggregating the analysis for individual components of the home to more accurately represent the distribution of energy loads. This will offer more granular information that better describes the impact that energy-efficient retrofits have on houses in Canada. For the costing data extraction, we want to highlight an example of what an actual invoice that we used to test the viability of our current AI and machine learning product. We chose a low-quality image to really test our code, with personal and identifying information taken out. Our code uses PyTesseract, an optical character recognition tool for Python, to convert the image to strings of characters. The output from the LLM has high fidelity to the invoice, with almost zero training and only minor corrections needed. Also worth noting is that we've connected with NRCan's digital accelerator team to seek support for our language model and for utilizing NRCan's computing resources. We are also familiar with the Treasury Board directives on use of AI. Understanding the structure and flow of data is critical to our idea. Homeowners drive the generation of data through their home energy retrofits. After completing their project, they submit EnerGuide audit data and invoices to program administrators, which tend to be municipal and federal governments. We now have a critical mass of homeowners submitted data that is housed in the EnerGuide database. We also have a subset of the costing data that has been manually extracted from the Greener Homes program submissions. NRCan is the custodian of both of these datasets. While there is a substantive dataset of over 40,000 entries of costing information, there are many invoices that have not yet been analyzed at both the federal and municipal levels. This is where our AI machine learning product can bolster the size of the dataset and ensure that no data goes unused. Once our costing data and enhanced energy savings data are combined, the polished dataset will be periodically published to Open Government, where stakeholders across the industry will have access to it. Groups from the federal government, like our own department, will use this data to inform programming and housing initiatives. We have heard from stakeholders across the industry that this data is of value to them immediately. Researchers and software developers, along with government organizations, will use this information to study trends and inform innovation in the private and public sector. Groups like Volta, for instance, will use this data to support their web-based platform for energy advisors, and federal government organizations like our own NRCan, as well as CMHC, will use this data for future programming and housing initiatives. Municipalities are on the front lines of delivering energy efficiency retrofit programs. Groups like the Federation of Canadian Municipalities and cities such as Ottawa, Toronto, and Saskatoon will roll this data into their homeowner-facing programs. And finally, homeowners will benefit from this data. 65% of Canadians own their homes. As we push for energy-efficient retrofits on all homes in Canada, Canadians will need to be informed about the costs and benefits of the retrofit options available to them. The partners indicated on this slide have immediate use for the data that we will be providing to them. Once the data is published, we see it being used immediately, again, to accelerate home energy retrofits across the country. This is an example of the report homeowners get after receiving an audit. You must do an audit to participate in rebate programs. This report describes the retrofit upgrades an energy advisor would recommend for a homeowner to improve the performance of their home. Our data will be integrated into this report so that homeowners are aware of both the energy savings and cost ranges to expect for their recommended retrofits. Thinking more into the future, we can see this dataset coming to life in the form of interactive dashboards that connect with other datasets and are used to support internal analysis and program development. We also see an opportunity for homeowner-facing retrofit calculators to estimate the costs for upgrade scenarios based on regional energy and costing data. All to say, there is a significant and immediate impact for this data. So, in summary, we do have the best data available, and now we have a plan for making it useful. Our idea aims to address 4 of the major barriers that are having a profoundly negative impact on achieving Canada's carbon reduction targets for the residential sector. First, We want to implement new calculations to fill in the missing details on energy savings data. At the same time, we also want to leverage AI to automate the process of costing data extraction from invoices. Once we have our enhanced energy savings data and costing data, we'll combine the two data sets into one to improve the accuracy and depth of decision-making analysis. And lastly, we'll maximize the impact of the data by publishing it on Open Government. This will ensure that it is accessible to all of our stakeholders and all Canadians. Our idea leverages data that is already available and aims to unlock its fullest potential. That potential is to accelerate affordable home energy retrofits and reduce Canada's greenhouse gas emissions in the residential sector. Merci beaucoup pour votre attention. Nous avons d'autres diapositives.
Thank you very much for your attention. We have other slides available, and they are available in the language of your choosing.
I now invite the rest of your team members to put their cameras on. Thank you so much for the presentation. You can stop sharing your screen in a moment if you like, so that we can see everybody. And I am going to come over to our judges. Judges, who would like to put the first question to the team? Gabrielle.
Thanks very much. Merci pour la présentation. Merci pour.
Thank you very much for your presentation. Thank you for the overview of what you have presented.
Easy to follow, so thanks so much for that. Just so that just from my perspective, I used to know this data, I don't know it anymore. The data calculations from EnerGuide, you talked about new calculations. Are you asking for new data entries or are you actually just doing new calculations? Just to understand sort of the sort of data burden here and what does that look like. But then from taking that information and creating your cost savings information with the OCR and the NLP for your natural language processing, are those efforts internal to the data set, the data platform that you're going to create, or is this something as a net new platform that you're thinking of to be able to put that into the open data space? Thanks.
Who would like to answer that question? I think Lucas and Daniel, you're both nodding to that one. Lucas, you first, then Daniel, then anyone else, and then Simon. Okay.
Perfect. Yep. So I'll answer the question around the new calculations. So we are not asking for new entries from homeowners. We are simply taking the data that already exists and applying these new calculations to unearth almost new insights from it. So it's leveraging existing data and finding new ways to shape it and analyze it to extract new learnings from it. And maybe I can turn it over to my colleague Daniel to talk about how we're going to be incorporating AI into these activities.
Thanks, Daniel. And then Simon wanted to come in as well, I think.
Yeah, so on the AI machine learning portion of this, the main thing we were trying to address is this very inefficient process that's taking place at Natural Resources Canada in moving the costing data over to a database. Historically, it's actually been done through a student hire program where students come in and manually input all these invoices that are received into a database. We want this program to be sped up and being able to take in thousands of invoices at once. Now, currently, it can just be input into an existing database, and it can be used as a support tool, keeping in mind the possible impact of automating decision-making. We have already run our proposal through an algorithmic impact assessment, and with the proper mitigation measures, this could be a level 1 and at most a level 2 program that we're proposing. So thankfully, the AI machine learning piece is really a support piece as opposed to completely taking away any sort of decision-making from an individual and really enhancing someone's already existing work process.
Thanks, Daniel. Simon.
Just to add to what Lucas said, we're not adding new inputs. We're using the existing data that's already available. The reason I wanted to add more on the reason why there's so many, like Lucas mentioned, 438 equations and many validations, that's because there are many types of retrofits that can be done, like replacing windows, wall insulation, attic insulation. So there are many retrofits. There are 5 fuels that we can model: electricity, natural gas, wood, propane. What am I missing? Anyways, and we're we want to be extracting both the savings and the greenhouse gases for each of those. So that's 5 new fields for energy data, 5 new fields for GHG data for each of the retrofits that can be modeled. So that's why it is such a large endeavor. Thank
Thanks,
you.
Simon.
Can I just add a quick follow-up question? Do you mind? Sorry about that. Thank you for those explanations. Really appreciate it. So the invoicing information, is it easier to go with an OCR NLP than to actually build a form or a data intake? Because to me, you're taking paper and then you're transforming it. Why wouldn't you automate that and put it in and think about the data sort of first perspective of ingestion? Thanks.
That's a really good question, and a lot of it speaks to the people who are generating the data and the breadth of users across the country. So it's energy advisors, it's homeowners, it's contractors and installers. So they're responsible for submitting invoices to municipal programs as like proof of the retrofits that have been undertaken. And so you can imagine every single company has their own standardized format or has their own format for an invoice. So we're taking kind of a walk first, then run approach, where we're trying to automate the extraction of this data, knowing that it will probably be a much bigger endeavor to try to standardize the way thousands and thousands of individual companies across the country submit their invoices to us. Although that is the ideal and certainly a part of our grander vision.
Thank you. Who judges? I'm going to come back to you. Yes, Erica, over to you.
Thank you for the presentation. I kind of have 2 questions. One is the data's already there. Have you already done it or done a proof of concept to see the feasibility it's actually going to work? Since you already have the data. Second question is, I'm a homeowner. I had to make some decisions. I don't know what I was doing. So like as a homeowner, how can your open data set that you're proposing to help me make a decision around how much I should invest and where I should invest? So what would I see as a final product from a homeowner? And also, have you explored other communications, not communications, like your product delivery in other means other than open data set, because not everybody will download a data set. I didn't. That's the last place I looked.
Thanks. So who would like to ask 2 parts of that question? Have you done a proof of concept and kind of how useful is this for her? Simon, you want to come in?
Yeah, I can answer the first part. Yes, we've developed a complete methodology, hence the reason why we can tell you that there are 438 equations exactly. So at this point, it's a manual process. So we extract the files from the database, we run them through an Excel extractor, and this is where in a huge Excel file, these equations are run through with the data, and this is how we're able to extract it. So we're able to do it, but it's manual at this point. And our idea aims to do this either directly in the database or outside of it, but like directly with the data as opposed to be a manual extraction, and then to do it on the software side directly so that we can extract the data from the data we already have, but then from the software side, as we get new files, we will already have the new data directly from the software. So it needs to be done in 2 different ways. That's the part I wanted to answer.
Thanks, Simon. Lucas, do you want to come in on the homeowner point?
Sure, I would love to. So yeah, great question. How will homeowners actually see this data? And you're right, no one's going to go and download a data set off the internet. And so one of the images that we showed in our PowerPoint presentation was an EnerGuide label, and as well as the report. So in that report, your energy advisor, who maybe you've had come to your house and do like a blower door test on it, they would have measured the house and recommended retrofit upgrades to you. So in the past, you would have just seen the retrofit upgrades and, okay, they saved me this much energy. Now we're going to be able to inform homeowners as to how much they could expect to pay for those retrofits. Even further to that, you're going to be able to see how much your neighbor paid for their retrofits. And so we can start to aggregate this data to make people feel more comfortable with making these big spending decisions. And then the other method that we envision this data making its way to homeowners is through homeowner-facing tools and calculators. Those are being developed by private organizations, software developers, as well as municipalities. So for instance, the City of Ottawa is developing a homeowner retrofit portal. Homeowners will be able to go into that portal, see what retrofits are going on in the City of Ottawa, what incentives and grants are available to them, and see what other people in their neighborhood have spent. And so that kind of provides the more wholesome full picture when you're making the decision to spend tens of thousands of dollars.
Thanks, Lucas. Judges, I'm coming back to you. Who would like to ask that? Yes, over to you, Wesley.
Great presentation. Really liked it. And my question is more the technical behind, because I'm interested in it. So 420. So I see a house as a system. Okay, sure, you can change the windows, but there's other parts of the house that's going to, that's going to impact your energy efficiency and so forth. It all works together. Do we feel comfortable that these 438 equations, because essentially what you need to do is model the system, and it may not be, you may not have the answer, because from what I understand, you're getting this from NRCan or whatever, but I'm curious how well these 438 equations can actually model such a complex system.
Who would like to take the technical question? I think
I'm
Lucas
happy
and then
to.
Simon. Yeah.
Yeah, absolutely. So I would say that those 438 equations are new equations, and they are in addition to an energy modeling software that has completely been validated and tested from an engineering perspective. So that is what HOT 2000 is. HOT 2000 is able to accurately measure the performance of a home while taking into consideration the house as a system. So how much insulation is in your walls and in your roof? What type of heating system do you have? Are your windows 20 years old, or are they 2 years old? All this information gets captured in this energy modeling software, and out the back end comes a overall estimate of how much how much energy the house will use on an annual basis. These additional bits, these additional equations help us to better understand the individual components of the home. So when we want to disaggregate it and say, well, how much do the windows save us specifically? How much does the insulation save us specifically? We're able to provide that information back to homeowners rather than providing it at an aggregated level.
Thanks, Lucas. Simon, did you want to add? And anyone else from the team,
Yes,
feel free to come in as well. Simon.
Yes, that was a great question. Thank you. Yes, HOT 2000 is built around the fact that we consider the house as a system, and using the information that's already outputted from HOT 2000, such as the heat losses from the various components, the efficiencies of the various heating systems and hot water systems, and all of the interactions between all of those. This is where we need all these equations in order to treat that information and extract which part of the improvement goes where. Sorry, it's a shorter explanation, but I think it touches on what you were saying.
Thank you. I'm conscious of time. I just want to make sure, does anyone else want to come in on questions you already have? But Elise, have you got a final question?
Yeah, just a quick question. It always sounds so fine and dandy, but I was just like to hear a little bit more about the challenges that you see in implementing this, because we've had some experience with complex model in agriculture where I come from, and there's always a reticence in putting it out there and having people make decision around those things. There's liability, there's other things that come into play. So I'd like to hear what the team has in mind for that.
Thank you. So we've got I think we've got 2 minutes left to cover the challenges. Simon, you had your hand up, and then I'll see if anyone else wants to come in. Simon.
Un de nos défis, oui, on a une preuve de concept.
We have a proof of concept. We tested our methodology with maybe 20,000 files. One of the main challenges will be to have, let's say, 1 million files in order to envisage all the consideration, all the situation that we haven't maybe considered that will modify the number of equations. That is what I wanted to add. Thank you.
And then Fred, and then Daniel, and then we'll have to finish there, I think. So Fred.
Thank you. Maybe just to complete on Simon's answer there, I was at the origin of the Green Homes program when we designed the program before launch, and same thing for the loan program. If we would have access to that disaggregated data at the time, our life would have been much simpler, much more efficient in terms of doing that, because we had essentially to do a lot of reverse engineering when we designed those programs there, where we had to start from the data, the house level, the house system level, and we were lacking decision points or very disaggregated data on the measure by measure that we wanted to put forward. So this will be, I think, one way where the broken down data and the inputs will be extremely helpful, not just for us at the federal government, but for all the other provincial partners and municipal partners that we're working with and that are using also our data set to influence their own and shape their own programs and policies.
Thanks, Fred. And then Daniel, I'm going to have to ask you to 20 seconds, I'm afraid.
Thank you, Siobhan. Just on the AI machine learning piece, one of the challenges we did identify is where this sort of program would actually be hosted and the protection of the data, as it could be sensitive information. But luckily, we've identified that the government might not actually need to have its own hardware and instead can leverage the contracts and the negotiations it has with cloud service computing partners such as Amazon Web Services.
Thanks, Daniel. Judges, is that all okay for you? Brilliant. Thank you so much, Team 6. Thank you for your great presentation. Really, really interesting. Good luck to all of you going forward. And I'm now going to invite you to leave the call. Thank you to all of you.
Thank you to everyone.
Thank
Take
you.
care.
Bye-bye. There we go.